Alright, this is our final lesson in this unit. Same as last year, we were going to solve systems equations algebraically. Here's a grade 10 example to start us out. And of course, solving this means we need to find all values of x and y that are going to make both equations true. Okay, and question 2 asks us to do this by substitution. So we've already got y by itself. So in the bottom one, I'm going to replace y with 2x minus 3. And now I can get all the x's on the same side. So I'm going to add x to both sides. Notice that those brackets don't do anything because, yeah, it's like multiplying a 1 through. So I get 3x minus 3 equals 6. Add 3 to both sides. And I get x equals 3. I'm going to take that, put it into the top equation. Doesn't matter which one I use. So our solution is 3, 3. Okay, notice this is exactly the same as the first example from lesson 5.6. So you can go look at the check there. Alright, and this is the same as the second example from our last lesson. Oh, I think I might have said 5.6 before. It was 5.5 was the last lesson, of course, where you'd look for the check. Okay, if you remember from last lesson, this system has no solution. So basically we're going to find out what it looks like when we're trying to solve by substitution and we have no solution. So again, we've already got y by itself on top. So in the bottom equation, instead of y, I'm going to write a half x minus 5. Multiply that 2 through. Collect like terms, and I get negative 10 equals 6. It should be apparent that no matter what I put in for x or y, negative 10 will never equal 6. So in this case, I have no solution. Oops. As we already knew from yesterday, we have no solution. And again, question 4 is exactly the same as it was in 5.5. So I'm going to do substitution here. Notice in the top one I've got y by itself, so I'm going to replace y with this in the second equation. So again, these brackets can just go away because they have a 1 multiplied through them. So I get x squared minus 4x minus 2 equals negative 2. I'm going to add 2 to both sides. I get x squared minus 4x equals 0. Super easy to factor. I get x times x minus 4. So x is going to equal 0 or 4. Okay, and might as well use the first equation just because it has y by itself. So when x equals 0, y is going to equal negative 2. So one solution is going to be 0, negative 2. Notice exactly the same as yesterday. This is a point, right? So 0 and negative 2 are a solution. 4 and negative 2 would not be. But when x equals 4, I'm going to end up with I get y equals 6. So here's my other solution for 6. And as I said, this is exactly the same as question 4 from last unit or last lesson. So the checks are already done there if you'd like to see them. And they do verify that when x is 0 and y is 2, it makes both of those true. And when x is 4 and y is 6, it makes both of those true. Okay? So it should be clear to everyone now that we've done 3 of the exact same examples, that this is just another way of finding the solution, right? So if I just asked you to find the solution, you'd have your choice. You could do it by graphing, you could do it by substitution, as long as you find those x-y combinations that make both equations true. And question 5 is a brand new question we didn't see yesterday, but shouldn't be that big a deal. We're just going to do substitution, same as before. So let's take the y from the top equation, put it in the bottom one. Okay, and again, these brackets aren't going to do anything, so let's just move everything over to the left-hand side. Add x squared to both sides, minus 6x from both sides, and add 7 to both sides. And to factor this, I'm going to need two numbers that add to negative 13 and multiply to 30. So that's minus 10x and minus 3x. And factor by grouping here, the only thing I can pull out of this is an x. And this one I have to pull out a negative 1. So either x minus 1 equals 0 or 3x minus 10 equals 0. So x is going to have to equal 10 over 3 or 1. Okay, let's do the easy one first. If x equals 1, I'm going to throw it into the bottom equation. Y is going to equal negative 2. Oops. So one solution is x is 1, y is negative 2. Our other possibility is when x is 10 over 3. Notice you wouldn't be getting this exact value for x if you tried to do this by graphing. And we've got a common denominator of 9. So 60 over 3 is the same as 180 over 9. And then minus 63 over 9. So y is going to equal 17 over 9. So our other solution is going to be, that's not a very good 3. It's going to be 10 over 3, 17 over 9. Okay, so let's make sure that these x-y combinations make both of these equations true. So let's start with the easy solution. Make sure this makes both of them true. Negative 2 equals 2 minus 7 plus 3 is true. And negative 2 equals negative 1 plus 6 minus 7 is true. Alrighty, let's get a little fraction practice in here so that we'll be ready to go for Chapter 7 and to be able to do pre-calculus next year, or to be able to do pre-calculus and calculus next year. More for calculus next year, actually. Okay, so let's check the first equation. And again, common denominator of 9. So 70 over 3 is the same as 210 over 9. And then plus 27 over 9. So I get 200 minus 210 is negative 10, plus 27, 17 over 9. So that guy works. And second equation. Oops, that's not a plus, that's a minus. Again, 60 over 3 is the same as 180 over 9, and 7 over 3 is 63 over 9. So 100 minus 180 is 180, minus 63 is 17. Perfect. So we get 17 over 9 equals 17 over 9. So when x is 1 and y is 2, it makes both of those equations true. And when x is 10 over 3 and y is 17 over 9, it makes both of those equations true. So they're both solutions. Okay, and now for a somewhat contrived word problem out of the textbook. We've got two numbers and some equations. So part A, oops, that's a highlighter. Part A, first thing we need to do is define our variables. So let's say x is the first number, and y is our, let's use equal signs, I guess. Y is our second number. Okay, so 2 times the first number minus 5 is equal to the second number. Easy enough. The sum of the second number and the square of the first number is 115. So the second number summed with the first number is 115. Okay, and now we're all ready to do substitution because we've got y by itself at the top. Oops, what did I miss there? Squared. There we go. Okay, and subtract 115 from both sides. So I get x squared plus 2x plus 120 equals 0. It's not plus 120, it's minus 120. There we go. So that's easy to factor into x plus 12 times x plus 10 equals 0. Which means that x is going to equal negative 10. Oops, that's not plus 10. Making tons of mistakes here. Minus 10. Which means that x is going to equal 10 or negative 12. So if x equals 10, y is going to be 15. So 10, 15 is one solution. And if x equals negative 12, y is going to equal negative 29. So negative 12, negative 29 is also a solution. Okay, so let's plug those into the original equations and make sure that both of those sets make them true. So our first set was 10, 15. (20 minus 5 is 15). And 100 plus 15 is 115. And our other set was negative 12, negative 29. Let's make sure it makes both equations true. Negative 24 minus 5 is negative 29, so that guy's good. And negative 29 plus 144 equals 115. So we have two possibilities. the first number can be 10 and the second number can be 15, or the first number can be negative 12 and the second number can be negative 29. And I would write that out in a sentence normally, but my writing is horrible, so I'll just go with the fact that I said it, and you guys can write it down.